Now we are on the AI Awareness and Ethics Volume 4. And in the past volumes, we talked about the AI definition and who coined the term. We also talked about how we use it in different applications and what are the stages of AI, the 10 stages of AI. So now we're going to talk about more the machine language, how does it work, and we're going to get some examples about that. Okay, so after we went through in depth with all the stages, the 10 stages, here we try to go back to the discussion of different types of AGI. Not only AGI, but also all types of AI, because later we're going to look at the algorithms and the critical thinking behind it, and the science and the logic behind it. But in summary, those are the ones that they're going to be active as we speak now. So the first one is the artificial narrow intelligence, ANI. This stage is execute specific focus task without the ability to self-expand functionality. And this is achieved now. This is the stage we are in now. And this stage will outperform humans in specific repetitive functions such as driving, medical diagnosis, and financial advice. The one after that, and it's targeted for about 2040, is artificial general intelligence, AGI. It will perform broad tasks, reason, and improve capabilities equal to humans. This could be the stage where the AGI will be able to earn university degrees and convincing humans that it is human. So this is a little bit of a concern stage when we start talking about, artificial intelligence that would compete with humans in different areas and might even replace humans in specific professions. And after that, the artificial superintelligence, ASI, it's the timeline for it is soon after AGI, but some predictions say that this stage will be available in 2045. This stage demonstrates intelligence beyond human capabilities. So this is a stage we need to watch out for. We need to be able to control the objectives of this stage so it doesn't expose humans to any kind of threatening. So as we went through all the 10 stages of AI as some of the scientists define it, we can realize really these are more from the conceptual point of view, not from the practical point of view. Because unless they really produce or develop each one of those stages, at this point it's hard to say that these stages, we as humans will be able to reach that kind of sophistication and complication in computational models in general. And I will give you an example for that. 6 months ago, the self-awareness AI, which now is stage 7, it was actually stage 5. But then when the scientists, when they start working on the self-awareness stage, they realize that the technology as we have today will not allow to do something like the self-awareness because it needed a new computational model, which is a quantum computational model versus what we have now, which is the binary system. So that's why they moved it to stage 7, and stage 5 became AGI. So when they get into each stage, they're maybe realizing that there's something missing that needs to be done first. Um, at this point, we hear from different companies about the progress in coming up with the quantum model. We hear from IBM, we hear from NVIDIA, but we hear also different time frames. So some think will be done in 10 years. Some say, no, it's going to be sooner than that, even maybe 3 or 4 years. So at this point, we need to watch what these companies who are very much advanced in developing AI solutions. And based on that, things will be modified or altered or changed. But assuming that we have the 10 stages as we described, so what do we need other than that? So here I'm listing some of the future discoveries that's needed to be developed in order for the scientists to be able to come up with the 10 stages as they defined. So the first one is really the machine learning basics. This is understanding the foundational principle of machine learning, including algorithms that can learn from and make prediction on data. And we spoke about the machine learning life cycle and how it's performed and how the data scientists prepare the model to solve specific business situation. And within that, we have the supervised learning and the unsupervised learning. And these are two different types of learning and they are part of machine learning concepts. So with supervised learning, so the scientists using labeled data set to train the model so they can classify data or predict outcomes accurately. Versus the unsupervised learning, the scientists here, they working with unlabeled data, and then the AI will be able to, or there will be some kind of computation model that will allow the AI to find the structure in the data that they submitted, and so they can learn from it. So what they do is taking that structure of data, they cluster it differently, they look at the dimension of the data, and they make alterations or massage the data to be able to understand the objects that the trainer fed the machine with, and make sense out of it. Deep learning, as I mentioned earlier, it's considered really the deep learning is very, very sophisticated, very, very complicated, but it's also based on the human neural network, or I should say the human brain. So with deep learning, with the AI implementing neural network with multiple layers that can learn from complex pattern from large amount of data. And we're going to look at that in more details later. Now, when it comes to translation and natural language processing, they're looking at the model that will enable the machine to understand and interpret human language, facilitating tasks like translation and sentiment analysis. We do have now some software that will allow that to happen. But they also looking at how to optimize it so there will be no errors in the translation. And again, the computer vision, which is used in so many ways, That needs also to be more advanced than what we have now, to allow for image recognition, allow for the autonomous car to be able to see the objects around them and predict what they are. Also, it's used in reading the MRI, CAT scan. So the more advanced they are, the less errors that the machine will produce. And the next item for future discoveries is reinforcement learning. So that's one type of learning that the machine can go through to make decisions and take certain actions. And the reinforcement learning is based on receiving rewards or penalty based on if the machine makes the right decision, so it would be some kind of rewards. But if the machine makes the wrong decision, it would be some kind of penalty. The reward here means, whatever decision the machine came up with at this time would be part of the memory and would be stored as a fact. When it comes to penalties, when the machine make a wrong decision, and in that case, the algorithm have to go back and start all over again to do to work on the decision making here. And number 8, we need an AI that work in a large scale, because we're still talking about smaller scale. Like when we said that the AI is used in specific industry. So the IBM Watson machine works in healthcare. OpenAI maybe works on ChatGPT. Some are working only on games, chess games and others. But we need an AI that can work on all kind of practices and industries. So we need an AI at a larger scale. And number 9, it's the AGI. We described that earlier. But we need that AI system that possesses the ability to understand, learn, and apply knowledge in a way that is indistinguishable from human intelligence. And then, of course, with any kind of technology, we need to keep an eye on the ethical use and the regulations that the government and other institutions are put together to protect us and protect, the users. So I mentioned before about machine learning and deep learning. So here we're going to get down to more details about what does machine learning mean. What does it require for a machine to be able to learn on its own? And some of the applications that different machine learning use, or I should say algorithms that they use for different applications. So we see here the one in the middle, the machine learning, and different groups within machine learning. You will hear a lot about supervised learning and unsupervised learning, or even semi-supervised learning, and reinforcement learning. And this type of learnings used for different reasons. Some of them they used for image recognition. Some of them used for making decisions. Some of them used for translation. So different applications require different kind of machine learning. The beauty about it is now we do not need a developer or a programmer to write programs for that, because these algorithms are already loaded to the AI, and it gets processed when there's a need for specific function to be processed. So the question now is how we apply different algorithms to, excuse me, to different applications. So the picture we see now is for an autonomous car like Tesla. And when the car is in the still at the manufacturer or the shop, it goes through a lot of training in order to be able to detect elements or detect objects and be able to take all that information and then make a decision about where the status of the car to drive on the road or stop or turn, whatever is needed, the same way when we drive our cars. So when the car, as I said, it's still at the manufacturer, the data scientists teach the machine how to detect these objects. So in a way, it's going to go through a lot of inputs and a lot of pictures for different objects around usually on the street. Could be a bus, the way different bus looks, and different cars, different street names, different road conditions. So it feeds it all this information, and it could be thousands of information that is the data scientists use to train the car. And when the car is trained well, then it goes to the dealer, to be sold. So when it comes to the algorithm here, the algorithm it's first used for training the car is the deep learning algorithm, because with deep learning it allows the trainer to train the car with a lot of information. As I said, could be thousands of information or thousands of objects. Then at this point, the car learn how to detect any object and then make a decision. But because the situation with the cars on the road, we need to make sure that the decision is almost perfect. And as I said, almost, because usually there's a small kind of error, maybe 0.001, but the fact that the trainer will do everything possible to allow the car to make the right decision. So after it goes through deep learning, after it's done that step, it goes to another algorithm, which is called reinforcement learning. And I think we saw those two algorithms back there, the slide before that. And reinforcement learning even allowed the car to make even a better decision and make sure that decision is a perfect decision. Reinforcement learning, meaning that the learning will not stop, or the process of learning will not stop until the cars in the shop or the manufacturer really passed by all the kind of tests and was able to make these kind of predictions for objects, and based on that make the right decision. Okay, so as we talked before about the two concepts that made that huge progress in AI for the last 20 years, and the two ideas or the concepts that Jeff Hinton, he was the founder of these two ideas, is the machine learning, and the other one is deep learning. So here we're going to talk a little bit about, what does it mean? What is a machine learning? What's a life cycle? Which means it's the cycle that a data scientist go through every time he or she develop that kind of training with specific AI, regardless is a ChatGPT or autonomous car or natural language processing, whatever function, it goes through this type of life cycle. So we look here at a circle, and in the circle we see different colors. The first one here is the orange one, and it's called data acquisition. So this is the first step in machine learning cycle. So this procedure is really all about obtaining, compiling data from different sources in order to be able to test and train machine learning model. So let's just say we try to teach a machine to recognize a question like who was the first president of the United States, or who was the 10th president of the United States. So here the trainer will load a lot of information about about American history, specific, American presidents. So all the data about different presidents of the United States will be loaded. So when they were born, when they passed away, their achievement, their maybe the way their leadership, but all about each specific president. After that, it goes to data cleansing and processing. Here it's looking at the data it acquired or through the acquisition, take that data and then try to clean that type of data from any missing values or inconsistency or noise that doesn't fit into that kind of category. And then it goes to doing or assuming, making a hypothesis and see if the model will fit into that hypothesis. So the AI model that would be able to solve specific problem and training it with the prepared data. So let's just say the data trainer or data scientist here is training the machine. Devices here could be autonomous car, how to drive on the road. So the first phase was the data acquisition. So it acquired all the information about traffic lights, about objects. An object could be human, could be objects like other cars, buses, whatever. The kind of marks we see when we drive the car, all that information will be loaded to the server, and then they start the model or the AI here will look at the data, see if something doesn't fit. For instance, you don't want to know the president of the United States if you train a car, so it only keep the information that's needed for that kind of stage. And then after that, it will make some hypothesis, meaning that each problem has its own solution. So in case that you're doing language translation, for language translation has its own model, it has its own algorithm that goes through it. It has its own way of handling the information. But first, it's going to make that hypothesis and then see if that hypothesis really works with the data that it collected. And if it doesn't fit, it will go back again and make another hypothesis until really get to the point where the hypothesis that was made is the right one. Okay. After that, evaluation and interpretation. So once the model has been trained, it must be evaluated to see how well it performs. So it will test the model on unseen data, data that did not see before, analyzing it, analyzing its prediction. So if the model's performer is not satisfactory, okay, so it will go to be refined and tweaked, and that means it will go back, adjusting the model's parameters, changing the model's architecture, or even returning to the first phase, which is data acquisition. So after that, and the evaluation came out positive, and so the interpretation of that model fits into what, the business case that we try to solve. So once the model is performing satisfactory, it's deployed to a production environment. That means it's ready to be used. So if it's again autonomous car, now it can go to the dealer, and a buyer will come and buy the car. So it goes to that production environment where it can start solving real world problems. And then the deployment also involve maybe integrating with other models, because sometimes the app doesn't only work by itself. It has to be integrated with different other models so they all can solve specific, business problem. So okay, so as I said, we'll test the integration with the other models, and make sure it's all working together well. And if it's not, they're going to see exactly where the problem came from, and then work on that specific problem. So most of the model after that, they will need to be maintained, updated after deployment, because every day something new comes when it comes to technology. So this kind of optimization, always looking for a better way to handle that solution. It could be handled maybe the time to deal with the situation would be maybe less than before, so there's some kind of optimization here, or the accuracy would be higher with the new technology than the old one. So I mean, it's always going to go some kind of refreshing evaluation to make sure that all the pieces work together and we are getting the most optimized solution from the AI. Okay, so what exactly is machine learning algorithm? And the word algorithm here is the key. As I mentioned before, that the algorithm is becoming the backbone of artificial intelligence. When we say artificial intelligence, that really equates to hundreds of algorithms that the machine can perform without any type of coding, without any type of developer who develop code the old way. But all these algorithms are already ready to be used in the AI. So basically, algorithm is set of rules or processes that used by AI system to conduct task or perform task. And most of the time is to discover new data, to find patterns, or to even predict output values from a given set of input variables. So when we say predict output values is the same thing when we have the autonomous car or even ChatGPT or face recognition that can predict the image of that person, and then it goes through multiple processes in order to validate that prediction. And if the prediction is close enough to not like a high prediction or very valid prediction, that result will be the output of AI. So machine language algorithms are computation model, and we're going to see later how they all fit together and what exactly the math behind it. We're not going to dive a lot into math. We're just going to see how does it look and how we form that kind of model. So these models allow computers to understand patterns and forecast or make judgment based on data without need for explicit programming. And actually, the algorithm is the foundation, or another way, the backbone of the AI. And it's used in a wide range of applications, including image, speech recognition, natural language processing, recommendation system, fraud detection, and autonomous cars. Most of the things that we talked about earlier. So I was asked before to give some kind of information or insight about, what new skills or new profession that will be required as being we moving now into that AI global kind of usage. So we're not going to talk now about what profession that will not be required because it's hard to predict that. But the one that would be very highly marketable and requires a lot of skills, it's called data scientist. That's a person that has a combination of computer science, math, statistics, calculus, probability. Someone understand math very well, understand computer science, have the skill of Python language, which is now the language for AI, similar to Java and C++. So that kind of profession actually will have a great future and will be very marketable, not only in Silicon Valley, but all over the United States. So I'm giving you here example of what data science is about. So we have the big or the circle, the output circle, which is everything about artificial intelligence. part of that, a core of artificial intelligence is the machine learning, as we see before, which will have the algorithm and the training from the data scientist. And within the machine learning itself, there is a smaller circle, which is the deep learning. So deep learning actually, because it's a process, it's a very sophisticated process that will take thousands of information and be able to train the machine and come up with output. So that's why, I mean, it seems like a smaller circle, but in reality, deep learning is very deep, very sophisticated, takes a lot of time to execute, also take a lot of energy. I'm talking about power here, electricity, to keep the servers up. So that's part of deep learning. Then there's the data science, which really goes over all the circles, but there is also more outside of the AI because of the math and the statistic part of it. So that you see now the circle that says data science. This is the new skills that's required now in order to be able to join, I guess, the staff of AI scientists and developers.